This is the Unit 8 review for retest video part 2. We were just finishing up on this question of reviewing the properties of parallelograms, rectangles, rhombuses, and squares. We discussed parallelograms have 5 properties specific to them. Rectangles have those 5 as well as 2 more. Rhombuses have the original 5 as well as 3 more. And squares have all 10 properties because squares are rhombuses as well as rectangles, which are both parallelograms. Alright, so we're on to the last part. We're going to answer the questions at the right using the graphed vertices in the quadrilateral ABCD below. So first I'm just going to draw my quadrilateral. So I can have an image to work with. So we're going to find the indicated property about the sides of this quadrilateral. First, we need to find the length of AB, which is right here. So we have a couple different ways we could do it. We could use the distance formula. Distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. But my preference is to use the Pythagorean theorem. We do that by creating a right triangle with the side of the rectangle as the hypotenuse. See, it's a 90 degree. And now we can use Pythagorean theorem because it's a right triangle. This side is 1 unit long and this side is 2 units long. So now we can do a squared plus b squared equals c squared, where we're solving for c. A squared would be 1 squared plus b squared, which is 2 squared. And we are solving for c squared. So 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. Equals c squared, and then to get rid of the square we take the square root. So c, or the AB, equals the square root of 5. That is the length of AB, the square root of 5. Next, it's asking for the length of BC. Get my pen all situated. So BC, I'm going to do the same thing. I'm going to have this side BC be my hypotenuse. So I'm going to create a right triangle off of that. Do a little bit thicker lines for y'all to see. So now this side is going to be 1, 2, 3 units long, and this side is 1, 2, 3, 4, 5, 6 units long. So now I can do a squared plus b squared equals c squared. A squared is going to be 3 squared plus 6 squared equals c squared. 3 squared is 9 plus 6 squared, which is 36, equals c squared. 9 plus 36 is 45, equals c squared. Get rid of the square root. And the length of BC is the square root of 45. So this is the square root of 45. Part C, are the sides the same length? No. They are not the same length. This is the square root of 5 and this is the square root of 45. Next, we need to find the slope of AB. And slope is always rise over run. So I'm going to rise up to get from A to B. I'm rising up 2. And I'm running over 1, but it's a negative 1. So 2 over negative 1, or just negative 2. And then I need the slope of BC. And I've already written my stuff down, so to get from C to B, I rise up 3, and I run over 6, which reduced is 1/2. Are the sides perpendicular? Well, if they are perpendicular, then their slopes must be the negative or the opposite reciprocal. So the slope of AB is 2 over negative 1, and the slope of BC is 1 over negative 2. So the fraction is flipped, and this one was negative and this was positive. So therefore, yes, it is a negative reciprocal, and yes, the lines are perpendicular. So what does that mean about this corner right here? If they are perpendicular, this is in fact a right angle. Okay. Now we need to find the length of AC. We're dealing with the diagonals now. So AC is going to go right through the middle. Make that a little bit thicker so we can see the difference. AC, and then we'll do gray. The other diagonal is BD. So we need to find the length of AC. So finding the length, again, we can use the distance formula, or what I prefer is to find a right angle, a right triangle, and use the measurements from that. So we'll be doing AC first. So A to C, I'm going to create a right triangle just from here, just like that. So this side is going to be 1, and this side is going to be 1, 2, 3, 4, 5, 6, 7. So I can do the Pythagorean theorem again. A squared plus B squared equals C squared. So it'll be 1 squared plus 7 squared equals C squared. 1 squared is 1, 7 squared is 49. 1 plus 49 is 50 equals C squared. Square root to get rid of the squared. And C, or the length of AC, is the square root of 50. And I'm just going to leave it as a radical. Next, we can do the same thing for BD. So I'm just going to create my right triangle. This side is 1, 2, 3, 4, 5 units. This side is 1, 2, 3, 4, 5 units as well. And we can use the Pythagorean theorem again. So it'll be 5 squared plus 5 squared equals C squared. 5 squared is 25, so 25 plus 25 is 50. We take the square root, and the square root of 50 equals C. So are the diagonals the same length? Well, they're both the square root of 50, so yes, they are. Next, we need to find the slope of AC. So AC is right here. It's rise over run again. We rise up 1, and we run over 7. So the slope of AC is 1/7. The slope of BD, we rise, to get from D to B, we're rising 5. And we're running 5, which is reduced to 1. Are the diagonals perpendicular? Again, it needs to be the negative reciprocal. These are not negative reciprocals, so therefore they would not be perpendicular. Now, based on your answers to 9 and 10, what shape is the quadrilateral ABCD? Well, based on my answers, I know from this first part that the angles are 90 degrees. And I know from this second part that the diagonals are congruent. And the shape, but I also know that the sides are not congruent. So because all 4 sides are not congruent, I can automatically eliminate rhombuses and squares. However, the diagonals are congruent still, and they're 90-degree vertices. Therefore, this has to be a rectangle. And that's the end of the review. If you have done this and you tried it on your own, then you will hopefully be successful on the retest for Unit 8. Please ask your teacher for any confusion and any questions that you may have. Thanks so much.